Hello, everyone. It's been a while. Um, and I recently, on Monday morning, attended a talk by the lovely guys at IBM about doing retrieval augmented generation on their power systems. And this reminded me of a project I'd kind of wanted to do for a while, which is to actually build like some small scripts to do RAG on various systems that we have here at UCL. And I'd kind of been putting this off because whenever you look at sort of information on how to do RAG, it always involves installing a lot of sort of systems that run as services, right? So you either have a choice, you can get an OpenAI token and then pay to do your work, or you can install massive packages like Olama, which are, their own web server effectively. And that seems like a very complicated and annoying way of doing things. Um, I had a discussion with a colleague a few weeks back about how to do this, and he recommended I use a library called LlamaIndex to do it. And after the presentation that IBM gave, I decided to sit down and actually do this locally on our systems on Condenser in such a way that we weren't bothering using any API endpoints or anything like that. So what is RAG? So RAG is retrieval augmented generation. And what that means is basic from a user perspective, you're effectively using an LLM to search a database or a set of documents, and then summarize the results for you in a human readable format. So you think about you might have like a classic use is setting up a chatbot so that it knows about your organization's documentation, right? And this doesn't involve any training, and that's very important. So you don't need to spend a lot of GPU time to build a custom model. Instead, what you do is do some pre-processing of the data, load it into a vector database, and then when the user puts in a query, a database search is done and the results of that query are inserted into the prompt that the LLM then summarizes. Okay, so what are we going to use to do this? Well, since I'm wearing my, you can't really see this, but my Miskatonic University t-shirt, I thought I would do this for this demo on I believe now, public domain piece of text, one of my favorite horror books, The Shadow Over Innsmouth. Um, and we built a system using an LLM that I'm kind of fond of because it is devastatingly boring, as in it's really hard to get it to misbehave, and that's IBM's open source Granite 3 model. Granite 3, the 8 billion parameter version, runs very well on the GPUs in pretty much any of our systems. This is a very business safe language model. It's very hard to get it to swear or misbehave. In fact, I've not succeeded at all in all of my testing, and I really pushed it, or at least the previous generation of it. And so we use this as our LLM because we don't want our LLM, when it's summarizing things, to start getting too creative, right? The software library we're going to use is obviously we're going to use Hugging Face transformers underneath for running the models. But actually, on top of this, we're going to put LlamaIndex. And LlamaIndex is a really nice tool for doing RAG specifically. And as well as doing it in this way, it can hook into OpenAI and all those sorts of things if you actually want to use an externally hosted cloud service. I don't want to do that, but it's default mode is to call out to OpenAI if you've got a token set. The final bit we need is embedding model, and that's the thing that's really used to process the vector database so that it can be easily searched, and then that data can be brought back to the large language model. By default, LlamaIndex uses one from, I think, the Beijing Institute of AI or something like that. But we're just going to use the one that comes with the sentence library that is used as part of that, of the part of the LlamaIndex software. So how complicated is code? Well, I have made a fairly complicated version, and I mean fairly complicated. It's a whole 72 lines. What is this actually doing? Well, unfortunately, the way some LlamaIndex and Hugging Face's libraries are set up, they make use of a thing called pedantic, and they also override each other's namespaces, which causes some problems. So we're going to turn off some warnings. That's fine. Everything works. We don't need to worry about that. We're going to import some core libraries for LlamaIndex. specifically the stuff for the basic vector store database, a tool that reads all the data in a directory, and some stuff that allows you to set settings. And this is one of the parts that's essential for doing it locally, because without this, it will default to calling out to OpenAI. We're going to import a couple of bits of code that let it talk to Hugging Face, both for the embedding model and for the LLM. As general, we need to pull in like torch and sys and things like this. We're going to have some nice stuff just to make prompts look nicer that I put together a while back. You can sort of ignore that. And then at the top here, I've made it easy to set the embedding model and the actual LLM model by setting these variables, embedding model and checkpoint name, right? And so we're going to use the sentence transformers all mini LM L12v2 as the embedding model. And we're going to use our IBM Granite 3B 3.08 billion instruct as the LLM. This is a bit of dummy code here that just checks to see if we have a GPU. It actually doesn't really tell the LLM to use the GPU because that's done separately, but this just allows some nice debugging outputs so that if I'm running this on different machines, I can see what's doing. So again, this bit is not essential. The final thing is looking at the documentation for LlamaIndex. When they're running a local model and they're using Llama, they set some special functions in the LLM called messages to prompt and completion to prompt. And I found that's not essential, but if you don't do it, sometimes it messes up a bit more. So I replicated that code in a tiny library of external codes called HFHelper, which just does that work. You can find this in the documentation for LlamaIndex for running on local models. So what do we actually do? So first of all, read in the data from our directory, right? So instantiate a simple directory reader with the input directory data. So it will read in all the files in that directory. It can read text files and RTFs and a bunch of other file formats. Particularly, it's got plugins you can install which allow it to read Word documents, which might be really useful in a production context. And we're setting recursive true just so that it searches subdirectories as well. And when it's done that, we want to put the embedding model into that setting. Remember, we imported settings. We want to set the embedding model in there and set the LLM up. Don't worry too much about these settings. But don't worry too much about what they mean at this point. But these are things you can use to tune how the model behaves. We want to pass it those two functions we imported, and this is actually the thing which pushes it out either to across as many GPUs as you have available, or on CPU, depending on the machine, right? If we were super like benchmarky testing-y, we could set the mappings manually, but we only have one GPU in this virtual machine, so we're just gonna leave it at auto. So having slurped all that data in from that directory with the simple directory reader, we then use that to set up a vector store. And then we initialize a query engine from that vector store. And then after that, it's a very simple repeat loop where you read in a line from the user. If it's whatever command you want to have for exit, in this case, I've done by, you just exit. Otherwise, you send the query to the query engine, and it does the whole work of doing the search and passing the data to the LLM, right? And then we're just going to print out the results. The document you could use multiple documents. And I've done a very cool demo for internally where I've done the searching our internal documentation. For this, I'm going to use the text of The Shadow over Innsmouth, which is a wonderful horror story. If you've not read it, I strongly recommend it. This is an old enough piece of work that it is public domain, and you can get it from the HP Lovecraft archive, which I've done, and I've stored it as a rich text file format file in the data folder here. Okay. How many GPUs have we got in here? Well, with the help of NVIDIA SMI, we can see that I have a single 80 gigabyte A100 attached. And so now we can just run that short script, right? That 72-line script. So Python 3 frag.py. As you can see, it starts up, loads the model, loads the checkpoint shards from the Hugging Face cache on this machine. And then it should give us a prompt, and we should be able to ask questions about the book, right? So we can ask, for example, what happened in Innsmouth? What's happening now is it's doing a search, it's constructing a prompt, and sending that information to Granite to summarize, right? So what it presents you with is a summary of the information. Actually, this is a bit, if you've read the book, at the end of the book, where the author is saying like what the official version of the story is, right? But we can ask them other things like, did the narrator enjoy his stay in Innsmouth? And here we see some of the problems with this method, right? So what this method is doing is searching the text. And if you've read the text as like a intelligent human being, you will find that the narrator really does not enjoy his stay, because to understand that, rather than doing a search, you have to read the entire long section about what happens to him at night, right? So the text doesn't explicitly say the author did not enjoy it, but if in the sort of the amount of data you could put in a prompt, you can't really infer that, right? Um, should probably have said narrator. The other thing is it does you do sometimes need to be slightly precise in your questioning. Um, Again, if you read the entire book, this is the problem, right? So these systems are not great at picking up like subtext. So the subtext of the story, which I can probably spoil because this is a book from the 1920s, is that the author is distantly related to the people in the village and is starting to suffer some of the changes that they are undergoing. So if we do like describe the people of Innsmouth. So it's quite nice for summarizing text, but it doesn't understand things, right? It's a large language model. It's limited by what it gets in that prompt. Okay, let's exit that. I'm going to switch in our local data set now, just because that's interesting as well. And then looking at the ways that that fails is also interesting. So, ARC's documentation, both our internal information for staff and the information we provide to users about how to use our services are stored as markdown text in various platforms. So the documentation for users is read the docs server. Our internal documentation, and this is actually horrible. Don't ever do this. I think this has actually been a really bad change. Is a GitHub repository of markdown documents, and that is completely unsearchable. We used to have a wiki, but Central IT decided they didn't want to pay for Confluence anymore, and so it's been migrated. So if I switch what the data directory is, if I do an ls, you'll see that I've actually got a bunch of folders in here and data as a symlink. So let's move data and point it at the ARC dataset and rerun our little script. See, this time it's loading 1,173 documents, which is a lot more documents. Um, Okay, and so we might want to ask it the sort of question a user might ask, which is, how do I log into Myriad? Myriad being one of our HPC clusters at UCL, and probably the most used one. And here, it actually almost verbatim reproduces the text from the wiki, right? It tells you to log into SSH, tells you how to do it in PuTTY, and that's quite, so it works well, but it works less well with other examples, right? With LLMs, there's a limit. If you could think back to the, let me just find the code, the wrong window. So if we go back to here, right? One of the things we set is like how many tokens it can generate, right? 512 is probably not a lot for documentation, and a lot of things where you have like example scripts, they're a lot longer than that. But this is potentially sort of a very lightweight prototype of a chatbot that could be helpful to people. Obviously, a single A100 is a lot of resource, and so you'd have to do some tuning and look at some lighter weight accelerators. But if you think about how little code that was required there compared to, the implied code of calling out to OpenAI or another external provider, or the massive service weight of running Ollama or something like that on your machine, that makes the method look a lot more easy and a lot more palatable. So I hope you learned something. And go if you're interested. All these things are open source. Granite is a fantastic model. Go away and have a play.